In this video, we're going to be looking at doing the floor framing, and that is something that is gonna use this object over here quite a bit. So let's go grab a copy of that. And this is a custom Masterworks object. And let me give you a little tour of how it works to begin with. We'll bring it down here. So we'll open up the properties. Their properties are separated into specifications, overhang, and end cuts. End cuts more, seat cuts, 2D and 3D options. So this is a fairly new object, and it may get a little bit of an upgrade here soon, but this will give you the basic concepts. There are two different manufacturers that this can represent, Weyerhaeuser and Boise Cascade. It also allows you to do solid lumber. So if we go to Weyerhaeuser, these are the different series of joists that are available. If we go to Boise Cascade, these are the series of joists that are available. So here we have the I-joists, we have their LVL line, which is their beams, and then their rim board. Now Boise Cascade is carried by Dixie Line, and I think you have to go out of area to get Weyerhaeuser. Weyerhaeuser used to be our prime source, but now we're using more Boise Cascade. All ends up being about the same. So let's say we're going to use the 65,000 series. Then this shows you the different heights of that I-joist that are available. And you'll have to look at the stiffness. Apparently that's the only stiffness available for this series. For this little house, we'll do an 11 7/8, and we want our joists to be level. You also have the option to give it some slope, and you can give that slope in either rise versus run ratios, degrees, or percentage. So it just depends on the situation to determine what's going to be the easiest to use. So let's go ahead and just get going with that, and then we'll back into some more choices. So here is our, now this is mirrored. We always want to turn that mirror off. The mirror can cause a few, not glitches, but it just easy to get confused. Let's put it that way. So what this is our home point. That's our 0 point. And we're able to, in this case, I have the extensions off. So all we have is the ability to extend this forward and backwards. And I'll show you what this other node does in a few minutes. So we can change the length by dragging. We can, I'm going to use Shift F3 to look at just that joist. I'm going to change the to, let's see. Maybe I just need to move the sun around. Yep, good enough. And this material, maybe change the material. Yeah, we have a leather beam. That might be a part of the problem. So here we'll use OSB. You have two different materials. You have a engineered surface and then a solid surface, so you can distinguish. The lights are on. So here's the joist, and in this mode in 3D, again, we can extend the beam back and forth. So now let's look at some more of the properties. So we'll go back up here and we'll give it some rise and run, do a 4 and 12. So it's assuming the run is 12 inches. Here it tells you that. Okay, and so here's our 0 point. And we can turn on the seat cuts. So I'll put a bevel shim, because you really shouldn't put a seat cut into an I-joist. And we'll do a bevel shim here. And we'll make those shims 4 inches. So that'd be like 1/2 inch plywood and 2x4. And there they are. So this beam would need a little bit of an overhang. I'll show you that in a second. So that works because the 0 point is right at the tip. Here we have right at the tip, there's the shim. So that works really nice. And let's go in and we'll give it some overhangs. So include overhangs. And so what that does, I'm just going to add a foot to both sides. And now from this working point here to the end is exactly 1 foot. We can extend this in 2D or 3D. It's going to maintain the 1 foot overhang and it's going to extend the seat cut. And you can do it here. And similarly, this is 1 foot, and here I'm adjusting the actual overhang, and I can key this in. These overhangs are horizontal dimensions, by the way, so that's measured exactly horizontally. We go back to the floor plan. Now we have our 0 point. Here's our 16 inches. Measure that to confirm. Yes, that's perfect. Here we think we left it at 1 foot. Perfect. Okay, so that works out very nicely. Now let's put in some cuts. Well, first of all, we'll change the angle. So we'll do 20 degrees and 20 degrees. And you'll see that the positive angle makes it larger. So here, and it's 20 degrees off the plumb cut. So we're 20 degrees off of plumb. All these are always off plumb, never off of, never off perpendicular to the member itself. It's always off plumb. Okay, and then we go back into 2D, and the last thing I want to share with you is the ability to control the end cut, bevel to horizontal or bevel to, these are, I think right now it's only beveling to horizontal. So what does that mean? That's the base cut. And what this is, this allows us to take and control our end cut. So we have the ability to move this point. So I have my overhang. I can keep the 1 foot. I can go to center, and it actually is snapping to center. And then I have these angles, and I can go 45, 45, and I'll just make the other one the same. Back to center, and done. And then if we look at it in 3D, we got this nice coped end, and depending on what we're doing, this is going to be very helpful. And obviously, do back cut sometimes. This may be more common. Okay, so should work well for you. And now what's nice is I can take all the same information and say, we need to make this a bigger joist. Just drop in size, it expands, but all the distances, everything remains the same. Okay. Similarly, if you want to switch to solid, obviously that's going to remove some of the parameters, but now it's a solid block. There it is. It changes material, and now we're actually able to do a seat cut instead of a shim. And this offset, so when it's 0, it's going to give you exactly 4-inch notch. If you, for whatever reason, needed to make it taller, You can see it actually copes it in, so it's 1/2 inch and dropped in. Similarly, if you want a less of a cut, you could do a negative. So it's a really flexible object. And now let's go ahead and get this going and show you some more features of this and how we want to approach doing our framing drawing. So I'm going to go to, we'll use Weyerhaeuser 230 series 11 7/8. So let's say this is the first floor of the house, and not a roof. This is actually over house. So we don't need any overhangs. We don't need any bevels. We're probably going to need, close that down, that down. No seat cuts. All right, so that simplified it pretty well. And there we go. Now I want to make this a rim. Well, I'll make another one a rim. Let's keep these properties alive. And we'll do a rim board. Weyerhaeuser has several different types of rim board. We'll do 1.25 inch rim. And we're going to frame to this corner, and then we'll come in 1.25 inches. We'll do an F10. Put this over here. And then we just want to, I think it's nice if we keep everything going in the positive X or the positive Y dimension. See if we can keep that pattern alive. So we're just going to start by getting our rim going all the way around the building. Wrap this up here. Okay, almost there. I get too fussy, but I guess you could want to stop and how you want. So we're going to capture the end. Great. Okay, so now we can go into 3D. F3. Bunch of beams that are at an angle and the wrong height. Great job. Okay, so we'll come in here, do that, and let's just do a single floor. Object, control that guy. our key, object, Control A, and we want all of them level. And I think we want them to be 10-1. And there's a nice feature that is helpful often, and this is probably a good time to use it, where we use house walls. And here we can see that all these are dropped to the floor. Let's go back and this again. And put the wrong field. There we go. Now we have all of the rim sitting on top of the wall. The outline mode is nice. It's easy to use. Probably don't need it right this second. So you just have to decide when it makes sense and when it doesn't. And then it's just a matter of taking this same object. That's what's great about this. And come in here, our 14.75. I don't know. Do the math. So we want a piece of plywood. Let's draw plywood. I always forget. I think center to center minus 3/4. So the first one. I think the first one wants to be 15.25. And then let's get the length correct. Well, it's already correct. Let's get the member correct. Works from the center, and do a Shift M for multiply. 16 inches on center. Bingo. Go to here. Now, if you have that problem, you're going to need to move that node over and then grab the black node. Something I need to improve on. And then we go at it again. Right? We won't, I mean, there's lots of little nuances to improve here, but that effectively gets us floor framed very easily. And then if we want to put a piece of plywood on there, which is a good idea, we can take a slab and 0.75 inches, make it plywood, and we can just follow the walls. Show that there. Oh. See what the height is. I'm just going to go 11 feet to start with. There we go. I was needing to refresh using a F3. So I didn't want to do the math. It's too painful in my brain. is no node there, so we're going to want to go there, and then F12, 11. And I don't love this material. We're going to do it right. We're going to modify this material. Doesn't look like I can get it from there. We'll go 3. Where? There it is. Leather. Probably not. Looking for plywood. Plywood. There we go. Nice. And that's a floor. And the other thing you're going to want to do is, for the model, not necessarily for the framing, is create another fill. And I'm not going to do it just like I did the ceiling in one of the other videos. So here's our framing. And now let me show you a couple of other features of this object. It is controlled by a special model view option, and you click framing plans, and all these lines, all those 3D representations turn to single line, which is nice because it makes your plan read a little bit better. And we can go look at our line types for our lines. Double dashed. Now, something to be aware of. This is override can sometimes be confusing. So make sure that you unselect those symbol overrides. Now I hit correct. Now, need it even more. Let's make sure we got the right line type. Default line type should be that guy. There we go. And the plywood, we don't really want to see the plywood, so we'll take the cover fill out. So the plywood's there, but we don't have the cover fill. So everything models the same, but we don't have to. We don't have all the line clutter from before. Now, a couple of other things. The display options. So you have your default line, and then you have a label line and a line weight. And so this is a heavier line. And the reason that's important is because I can go and say that you, and I selected one, are a label. And once it's a label, it darkens the line. If I do true line weight, you can see it is quite a bit heavier, and I can control that with my pen. I have the ability to move this label around as necessary. I can put a note here at 16 inches on center. That goes underneath. If there's a calc for this joist, I put J3 or whatever joist it is. And the other thing, so that's the label. So it changed the line type to whatever's selected here. Put the description, and then I have one more choice, which is label with extents. And it gives me this arrow, and I can take this and do that. And I got my nice light lines here. Got my heavy line for this one. I'm showing that all these joists are the same type. I can move this around anywhere that makes sense. It puts a little circle on the main beam. So however you want to use that. And if the label seems like it's in the way, I can slide it over. But there we have it. So that's how we're going to use the beam tool for doing a floor system. Obviously, if I had some structural beams that needed to go in here, which is simple. Now remember, it's much easier to do your modeling under the modeling radio button here, so you can actually see the 3D and you know how far to get to the center and that sort of thing. So if this needed a beam here because there was a wall above, then I would just take the same joist and just say, nope, you're actually a PSL 3.5 by 11 7/8. This weak axis takes the joist and rolls it 90 degrees, so you have that option if you need it. So it fattens that up, and let's put this on a different layer. And I'm going to actually ghost that so we can see through here. Which one of those did we? PSL 3.5 by 7/8. There it is. I don't know. There it is. Having a hard time seeing it. And so that's easy enough. And let's just do a few more little things here. Let's say we want to make this one the same. And then these would want to be upgraded to a label, not an extents. So these will be shown as being different. We'll make this one our label with the extent arrows. Great. And however you want to do it, you can do all the way from here to here and then do another one from here to here, whatever makes sense. Actually, I'm going to take this one and make that one. Let's bring this back. We'll do a little head out here. And so this is not the way you want to do it because that's not going to be the right length. So I'll get it close. But we want to go into the modeling when we get to that point there, because that went to center line. Notice that the edges of the beams are recognized. Do a head out. Take it. So gives you a nice little head out here. So works really well. If these really don't need to be beams anymore, so we can drop them down to joists again. So I think you get the idea. All right, I'm I'm going to stop here with that because it's going to be a long video and more to come.